So this time we will start date and time. Java's original date handling, java.util.Date and calendar was so problematic that we needed one entire new package or replacement for that. So we got that in Java 8, java.time package, a modern, immutable, and intuitive API for date and time manipulation. Understanding why the old API failed helps us appreciate the design decisions behind the new one. So first, let's see the legacy problem. So in this one, we have this date. This one is one legacy, and right now this one is deprecated. Okay, so Java shipped with this one, java.util.Date package in 1.0, and then later in 1.1 they added calendar, but also we got new problems with this one. So right now let's see the difference. First one is definitely mutability. See here, we created this one, right? So now we can change this one. So this one is a very big concern. And now in our new package, all classes are immutable. Next one is confusing months. Months are zero indexed, like January equals to 0. And in this new one, months are 1 indexed. Okay, now next thing we have poor API design. Date has time, no separation of concepts. In this one new one, separate classes for date, time, and combined also. Thread safety, simple date format, not thread safe. Date time formatter is immutable. So if anything is immutable, then that is definitely thread safe. Time zones, complex, error prone handling. So we have some problems here. So definitely you can avoid this one. We have new way here. We can create new class here, something features. Okay. Import this class. And you can also see we have one method here, static method, which is off. Okay. Now let's see java.time package. The new date and time API is built around a few core principles. First one is immutability. Every operation returns a new object. The original is never modified. This makes the classes naturally thread safe. Then separation of concerns. So we have different classes for date, time, date time, okay, beyond date time. We will see this one in our next chapter. We can use exactly what we need. Consistent API. All classes follow the same patterns of to create, plus minus to manipulate, get to extract, with to adjust, is to compare. Next one is human versus machine. Local date, local date time represent human readable dates, and instant represents a machine timestamp point on the timeline. Different tools for different purposes. We will see these. Now we have some core classes here. First one is local date, a date without time or time zone, something like this. Local time, a time without date or time zone, like this one. Local date time, date and time without time zone. Zone daytime, date, time, and time zone. We will see these classes here in this chapter. Okay. Alright, now let's see our first class, which is local date. So this represents a date without time, year, month, and day. Use it for birthdays, deadlines, holidays, something like that. We can import this one here. Okay, we can import month here. So current date we can create now, and specific date of this one, month.march, using enum. Okay, from string we can also do that one. So this of here is one factory method, not one constructor. We have just seen that one. So factory methods can return some cached instances. So we can validate before we create object. And this of method is, like we discussed here, consistent API. We will see this one in many classes, like here in our this java.time package. Okay, now we can extract some information here. Local date equals to this one, date dot get year, get month value. Okay, these things. So now you can see one difference like dot get month and dot get month value. So this one return enum and this one return like integer. So this API gives us both. Now next thing, manipulating returns new object. So let's say we have created this one. Now if we do any operation here like plus days, plus weeks, plus months, then we will get new object in our heap. And these two operations, we replace here specific component. Okay, like month with day of month one. Okay, first day of month, something like that. Every method returns a new local date. The original is unchanged. So like if you are not capturing this result, we have this one original and we added something here. Here we discarded this result, right? And if we print this one date, then we will get this one original, not this modified one. So always capture the result if you want to use this one. Okay. And if you just want to print, then that's fine. Original, modified. Okay, so you can capture here, you can print this one. Okay, now next one we have local time. Local time represents a time without date like hours, minutes, seconds, and nanoseconds. We can also get this one. We can use this one for store hours, alarm times, and scheduling within a day. Import this one from same package, and we can use .now, .off. We have different method signatures. So you can see we have same methods here like .now, .off in local time as well, like we have seen in local date here. So we have consistent API, and this one is very important when we have so many classes like local date, local time, date time, zone date time. So having same methods in all these classes is very helpful. Same thing, okay, with local time as well. We can parse this one here. We can extract some information. Again, in manipulation, we will get new object. So if we are doing something like this, then we will get new object. Now next thing, special constants. In this one, we have some. So local time dot min like this dot max. Okay, so if you can notice here, we can get nanoseconds as well. All right, local time dot midnight, noon. Now next thing, local date time. This one combines date and time without a time zone. So we can use this one for events where we know the local context. Again, we can import this one and we have same methods, local date time dot now. In this one, we will get date and then time, but without time zone, date and then time. So this dot off is for creation. Now is also for creation, combining date and time. So let's say we have one local date, local time. Okay, now we can combine these two things using this one, date and then time. Again, we have different method signatures for this one. Okay. Now next one is extracting and manipulating. So in this one, we also have some manipulation. So we can create this one here. And here also we can extract parts, like we can extract date, we can extract time, something like this. Okay. All local date and local time methods work here. Get year, get hour, plus days, like this. Okay, now next one we have comparing dates and times. All three classes support comparison using method calls, not like this. So let's say we have date one, this one, date two, this one. So date one dot is before, true. So this one is before, okay. Is after, false, is equal, false, false, same as is equal for dates. Work the same for local time and local date time. Okay. We can also use in ranges as well. So is within business hours. We can pass this instance. Return is before and is before. Is after. Okay, so we have same methods in local time and local date. Is before, is after. So these are also some benefits having consistent API. Now, when to use which one? Choosing the right class is important. Using the wrong one can cause subtle bugs, especially with time zones. We will see time zones later. Local date, date only. Local time, time only. Local date time, date plus time, no zone. This one is very important. No zone. Okay. Zone date time, date plus zone plus time. Used for anything crossing time zones, API timestamps, scheduled events for global users, and we will see this one. Now, next one is instant machine timestamp, used for logging, audit trails, database timestamps, measuring elapsed time, something like this. So mostly like storing. We can use instant class. We will see this one. Local date time is not a timestamp. A common mistake is using local date time to store event times in databases or APIs. This one is one mistake, okay, because our database or our server can be used in multiple places in world. So definitely we need some zone information as well. So without time zone information, this one is ambiguous. So in this one, we cannot tell from which country we are talking about. So is that this one in New York, London, or Tokyo? So for any system where time zone matters, we definitely need this one or instant. We'll see this one. Tactical patterns is calculation, days until an event. So you can see some things here. Some pitfalls, ignoring immutability. So if you have this one original object and if you are modifying this one, then our this result is discarded. And if we need this result later, then definitely we have to store this one in one variable, okay, one object. Next one is if you are using local date time when we need zone date time, then this one is one mistake. So if our application serves users in different time zones or stores timestamps in a database, then definitely this one will cause bugs. We can use this one or instant. Parsing without error handling. Local date.parse throws DateTimeParseException for invalid input. Always handle this when parsing user input. Okay, so we can see this one, and this one we will get in runtime, not compile time. So this one is one unchecked exception. And if we provide some wrong input, then we will get this exception. So we can create something like local date. We can put here 2026. So let's put anything here. And now if we compile this one, so no compilation error, but if we run this one, now we got this exception, okay, could not be passed. Now we have quick summary part, and now we can move to our next chapter, which is date and time advanced. In this one, we'll see like instant and zone date times.